Hi guys, this is Miss Raina coming to you from C347, brand new for the new year 2014 to talk to you about our new unit, soil. So you're going to see a lot of definitions on here, and remember, feel free to pause, rewind, fast forward anywhere you see something that you might want for vocabulary, for example, or something else that you can use in the study guide. A lot of people think about soil as just dirt, like it's something that you got to wash off or get rid of, but it's actually got really vital importance. A lot of people don't know that there are living things inside there, and I'm talking about the bacteria and the fungus, the microorganisms that are almost a network that connect everything together that lives off of the soil. The plants themselves anchor themselves in there, and there are lots of terrestrial organisms that burrow down deep into the soil and kind of process it for us. So it's composed of 4 distinct parts, and you've got the mineral particles, in other words, teeny weeny little rocks. Sometimes they look like sand. You've got organic matter, so that's broken down leaves, twigs, also maybe little broken down animals, and bacteria and fungus. 25% of it is water and 25% of it is just air, and those are important parts. They make the soil function the way it does. All right. We do consider it a renewable resource, but it takes about 100 years to mature about 1 inch of soil. So yes, if we get rid of it, we can wait for it to come back, but we're going to be waiting a long time. A soil is mature when it's got what we call soil horizon. So at the end of this, we'll be able to see what that means. Soil forms from parent material or big bedrock, and it takes a long time to break down. It can break down by things like physical weathering, the water freezes in the cracks and opens them up. Chemical weathering, things like acid rain. There's an argument whether it's renewable or not, and we're going to go into the soil triangle and things all about texture later on. Here are a couple of properties of soil. So friability doesn't have to do with like delicious food. It has to do with how easily the soil can be crumbled up. Porosity is where I was talking to you about the importance of air in the soil. How much distance is there between particles, how much space is there. It's important because that's space to soak up water. Permeability gets more, it increases the bigger the particles. So if the particles are very big, the water can permeate. If the particles are very small, they tend to hold on to the water. And if you notice, when you try to pour water through something like clay, it doesn't really go through the other side, whereas if you pour water through a big particle size structure like sand, it really does filter all the way through. So along with permeability, we've got particle size, and those two things are directly related. Just got a bigger picture of that there. Shrink swell potential is what makes your house move just a little bit in the drought. And you and your parents know this all too well. If you've got cracks in your foundation or around your door, it's because of the shrink swell potential of the soil underneath your house. pH of soil is very important. Here in San Antonio, we can't grow a lot of those big, beautiful, colorful flowers because our soil pH is pretty high. It means that we can't get a lot of those nutrients to dissolve out of the soil, whereas where they're very acidic, a lot of those nutrients can come out and they can support big, beautiful, colorful plants. Slope, how the depth of the grade on the soil is really important because it affects runoff. The depth of the soil is incredibly important, and you know this if you live, I think the basic rule is inside of 410. You dig about 1 inch and you'll hit limestone. Outside, it's a little bit different. We're going to see when we look around campus the variation in the color of the soils around here, and that'll tell us about nutrition, about content of the different compounds in there. Now we're going to talk about soil horizons, and here is a picture of actual soil horizons where you see the dark nutrient-rich soil at the top. Here's the kind of reddish soil in the middle down here, and way below is where you would see bedrock, and that reddish color indicates oxides. So the very top is the O horizon. We also call it the organic layer. Both of those names are fair game, and that's where the plant litter accumulates. So that's the different from the topsoil. The topsoil is the dark, rich, um, granular soil. It's not just the humus. Um, the B horizon is where the parent material has broken up, and so here you'll see a lot of metal oxides. That's where the reddish material was in the other picture. The parent material is the bedrock itself. It might have some weathered chunks of bedrock, but it's mainly rock, and you can't really call it soil. But that's how the layers break up, and they do that again because of the weathering at different levels. So you'll have physical weathering because of water, chemical weathering further down here because of acid, and the water as it drips down will leach a lot of those water soluble chemicals further and further and further down, which creates these layers. So in a mature soil, you see very, very well defined and very deep layers. For that to happen, you need a lot of water trickle down. So it means if you have different places like forest and desert and grassland, the soil horizons are going to be vastly different because the availability of water will be really, really different. So again, just to reiterate, the layers are caused by infiltration and leaching of water. The amount of water that's available determines how the soils mature. So here you can see in the desert, there is no O horizon. We'll be very, very lucky to get any topsoil at all. And really what you see is a lot of metal oxides, so clay, and some parent material. The exact opposite is a forest where there's lots and lots and lots of water available, and now you see very well defined layers because the water has been leaching chemicals through. The grassland is the ideal soil for farming because what's happening here is there's not too much water to leach away the chemicals, and there's not too little water so that no soil is formed. Like in the desert, it's like Goldilocks, it's just enough. So every year the grass dies, it gets processed, and it grows up again. It dies, it gets processed, and what happens is every year that new layer of very nutrient rich soil builds up, and so we'll have many, many, many feet deep of really, really good soil for farming. This is the breadbasket of America right here. The rainforest, a lot of people think would be really, really great for farming, except it's not. There's so much water coming down that it's taken all the nutrition away. And the only thing that keeps all of this plant life supported is a really vast network of fungus that lives very close to the top. There's so much water there that there's lots of metabolism going on in the soil, and you end up with really low pH, very acidic, light colored humus. So you're welcome to pause. You should do a couple of drawings of the desert layers, the grassland layers, here they are here, definitely the rainforest, and an example of a deciduous forest, some kind of moderate climate. Again, here's coniferous, and it's basically the same, just colder. All right, so thanks for sticking with me through this video. Be ready for a quiz over this material. Thanks, guys.